Zeal Education Society, redefining excellence.
Hello, good morning to all. Myself Dr. Mahadev Unde, Professor in Electrical Engineering Department, Zeal College of Engineering and Research, Pune. In this video lecture of Basic Electrical Engineering, we are going to learn the network classifications or certain terminologies. Let's start now. What is a circuit? What is a circuit? It is a closed conducting path in which current flows are intended to flow. Okay. Then what is parameter? Circuit parameters, obvious parameters. These are the elements of the circuit such as resistance, inductance, capacitance, etc. Okay. Then what is a node? It is a point or junction when two or more circuit elements are connected together. Okay? So node is nothing but a point or a junction when two or more circuit elements are connected together. Now what is a branch? It is the element one or more connected between two nodes. Then the E part, linear circuit. Linear circuit. The circuit or the linear elements, the circuit whose parameters, this circuit whose parameters does not change with changing voltage, current and temperature. They forms linear relation. They form the linear relation. Okay. Then non-linear circuits. The circuit whose parameter changes with voltage, current, temperature, etc. For example, diode or a metal oxide, metal oxide lightning arrestor. Okay. Then let's have the next one is unilateral and bilateral network. Unilateral circuit or a network. The circuit in which current flows in either direction. For example, wire, cable, transmission line, conductor, or a transmission line. These are the unidirectional circuits or unilateral circuits. Then the H, bilateral. Just a minute. Circuit in which current flows in either direction are known as bilateral. Bilateral network, then unilateral. The circuit in which current flows only in one direction. For example, diode operates only in forward direction, forward bias. Okay. Then you have to study the active network and passive network, or active network. The network which contains energy sources is known as active network. For example, So this is a active network which contains the voltage source as well current source or any one source. Okay. Then the next one is passive network. The network which do not contain energy sources. Okay, then the K lumped parameters the parameters such as resistance, inductance, say capacitance, are considered to be concentrated at one location for analysis purpose. For example, T and pi network of medium length transmission line. See, in the T network, the capacitor is assumed to be concentrated at the center of the line, and in the pi network, the capacitor is assumed to be concentrated at the two ends of the line, and which is half. Okay. So this is about the lumped parameters which are considered to be concentrated at a particular location. So, and then the distributed parameters. These are distributed throughout the circuit. Throughout the circuit, they cannot be separated. They cannot be separated or concentrated, separated at certain location. Okay. For example, long transmission line. The long transmission line, its resistance and inductance are in series, and assume that they are distributed all over the length of the line, and the conductance and the capacitance, they are shunted, and they are also considered to be distributed all over the line. Okay. So we have considered the distributed parameters. Now see, the another factor is what is a mesh or a loop? It is a closed path in which no element or node traversed more than once. This is known as closed path. So that is known as loop. It is a closed path in which no element or a node is traversed more than once. That is known as a loop. For example, let us consider the diagram. So this is 1, 2, 3, 4, 5, 6, and now pay attention here. And what is a mesh? What is a mesh? It is a closed path, or it is a loop which do not contain another loop. In it. It is a mesh is a loop which do not contain another loop in it. For example, figure 1 consists of first nodes. See, these are the junctions. The node at which two or more than two elements are connected together. Now here 1, 2, 3, 4, 5, 6. The number of nodes are here 6. How many branches are there? 1, 2, 3, 4, 5, 6, 7. So the branches equal to 7. Number of branches are 7 here. Now see the loops. Number of loops are 3. And which are these? We can travel. See, the loops are shown by the reading, this I1, I2 and this R. Okay? Or first, see, loop is a closed path. You can start from any point, but you should reach to the same point again. Say 1, 2, 3, 1, just a minute, 1, 2, 5, 6, 1, 5, 6, 1. This is one loop. The second loop is 2, 3, 2, 3, 4, 5, 2. And third one is 1, 2, 3, 4, 5, 6. So these are the 3 loops. And number of mesh. Here are 2 mesh only. Here are 2 mesh, that is the shown by the red ink. Shown by the red ink, that is I1, I2. Okay. And say, consider the another example. Voltage, say resistance, inductance, capacitance. See, this can be shown like this. Okay, R, L, C, P. Okay, this figure has, figure 2, how many nodes? Nodes equal to 2. Branches equal to 1, 2, 3, 4. Then mesh equal to 1, 2, 3. And loops. See, 1, 2, 3. These are the 3. Then fourth one is this one, fourth. Then fifth and sixth. So it has 6 loops. See once again. Okay, say I1, I2, I3. These are the 3 loops. Then loop from this direction, and it completes in this way. The second one is, one more is throughout the outer side. Throughout the outer side. And one more is, see, between this. Okay, so it has just 6 loops. I hope you understood the terminologies and classification of the network. But here also there are the how to simplify the network. There are some direct methods and some network reduction techniques. In direct method, the network remains as it is. There will be no change in the network, and it can be solved. The current flowing or a voltage across any branch can be obtained by using the Kirchhoff's laws. Then the superposition theorem, reciprocity theorem, etc. And another one is, if there are very complicated network, and in order to get the simpler solution, it is necessary to use the network reduction techniques such as the star delta convergence, then the Thevenin's theorem, Norton's theorem, etc. Now in reduction technique, obviously the original circuit is different and it is reduced to a simpler one. Whereas in the first case, in which the direct method, the circuit remains as it is, and by simply observation or by applying the Kirchhoff's laws, superposition theorem, we can find out the desired solution. Okay, I will stop here. Thank you very much.